There was something strange about Neanderthal women. For years, scientists believed they already understood who these ancient people were. Their skeletons had been studied, their tools had been uncovered, their lives had been reconstructed, piece by piece. So everyone thought the mystery had already been solved, but it wasn't, because the biggest secret wasn't hiding in their bones, it wasn't buried beneath ancient caves, it wasn't trapped inside forgotten fossils. It was hiding inside their DNA. And when scientists finally decoded it, they discovered something so unexpected. It completely changed what we thought we knew about human evolution. This wasn't just another archaeological discovery. It was one of the most surprising genetic discoveries ever made about our closest human relatives. Because the truth hidden inside Neanderthal women's genes raises a question almost nobody had ever asked before. How could an extinct human species still be changing us today? And the answer is far stranger than anyone expected. Up until this point, the mystery seemed almost impossible. If the biggest secret was hidden inside Neanderthal DNA, how did scientists recover DNA from someone who died more than 40,000 years ago? The answer begins with one of the greatest scientific challenges ever attempted. Ancient DNA isn't built to last. The moment a living creature dies, its cells begin to break down. Heat damages the genetic code. Water washes away fragile molecules. Bacteria consume whatever remains. Even oxygen slowly tears DNA apart, one tiny fragment at a time. Give nature enough time, and the entire genetic blueprint simply disappears. For decades, scientists believed that anything older than a few thousand years would be too damaged to study. They expected ancient bones to tell us stories through their shape, but not through their genes. Then everything changed. In the cold mountains of Croatia, inside a cave known as Vindija, archaeologists uncovered the remains of a Neanderthal woman who had lived roughly 50,000 years ago. At first, she seemed like every other fossil, fragments of bone, nothing more. But unlike most ancient remains, these bones had been protected by something incredibly rare. Thousands of years of low temperatures, stable conditions, and extraordinary preservation had shielded tiny fragments of DNA from complete destruction. It wasn't perfect, far from it. The genetic material was shattered into millions of microscopic pieces, each one smaller than a sentence on this page. Recovering a complete genome from those fragments would be like trying to rebuild an entire library after every book had been fed through a paper shredder, piece by piece. Scientists began putting the puzzle back together. Using advanced DNA sequencing technology, they compared millions of tiny fragments, matching overlaps, correcting damage, and slowly reconstructing the genetic code of a woman who had walked the earth tens of thousands of years before the first cities, before farming, before written language. Years of work, millions of calculations. One ancient genome. When the reconstruction was finally complete, researchers expected it to answer familiar questions. What did Neanderthals look like? How closely were they related to us? When did they disappear? Instead, hidden inside her DNA, they found something nobody had expected. Not a new fossil, not a new species, but an ancient genetic legacy that had never truly disappeared. What scientists discovered wasn't just another piece of ancient history, it was a piece of ourselves. As researchers compared Neanderthal DNA with the DNA of people living today, one discovery stood out above the rest. Hidden inside the genome of Neanderthal women was an ancient version of a gene known as the progesterone receptor. At first, it didn't seem extraordinary, but the more scientists studied it, the stranger it became. This wasn't a damaged gene. It wasn't a useless relic from an extinct species. It was still alive. Today, millions of people, especially those with European and Asian ancestry, still carry this ancient Neanderthal genetic variant, not because it survived by accident, but because it appears to have been useful. Progesterone is one of the most important hormones in pregnancy. It helps prepare the body for implantation, supports early fetal development, and plays a major role in maintaining a healthy pregnancy. When researchers examined women carrying this ancient Neanderthal version of the progesterone receptor, they noticed something remarkable. These women were slightly more likely to have successful pregnancies. They experienced fewer early miscarriages, less bleeding during early pregnancy, and on average gave birth to more children. An extinct human species may still be helping modern humans bring new life into the world. Think about that for a moment. A woman who walked across Ice Age Europe 50,000 years ago may have passed down a tiny genetic advantage that still exists inside people alive today. This completely changed how scientists viewed Neanderthals. For generations, they had been portrayed as evolutionary failures, a species that vanished without leaving much behind. But genetics told a different story. Neanderthals didn't simply disappear. Parts of them survived, not through their bones, not through their caves, not through their tools, but through us. Every strand of inherited Neanderthal DNA is evidence that our ancestors didn't just replace them. They met, they lived together, they had children, and those children became part of the story of modern humanity. Today, if your ancestors came from Europe or Asia, there's a good chance that around 1 to 2% of your DNA came from Neanderthals. It may influence your immune system, your skin, your metabolism, and in some cases, even fertility. The greatest surprise wasn't that scientists found Neanderthal DNA. It was discovering that evolution never completely erased it. The woman whose DNA lay hidden inside ancient bones for tens of thousands of years isn't just part of history. In a very real sense, she's part of us. And perhaps the most extraordinary discovery of all is that extinction doesn't always mean the end. Sometimes it means becoming part of the future.